Hi guys! Today I'll be demonstrating Advanced Concept 7, where I'll be explaining 5 different types of electron domain geometries using balloons. I'm going to be explaining the VISPAR theory. This is a theory that predicts the geometry of individual molecules from the number of electron pairs surrounding the central atom. So the first one we have will be linear. This is my linear. Nitrogen will be my example molecule. It has 2 domains and 2 lone pairs. The next one will be trigonal. For this, I'll use the molecule nitrate. It has 3 electron domains and no lone pairs. Alright, and for the next one, we're going to do tetrahedral. So I need 2 more balloons tied together. To another 2 balloons. And now we have tetrahedral. As you can see, there's 4 there. So for the molecule for this one, we can use methane, 4 electron domains, and no lone pairs. Alright, and then the next one, we're going to do trigonal bipyramidal. It is very similar to tetrahedral, except there's going to be 5 electron domains. And for this one, we're going to use the molecule phosphorus pentafluoride. It has no lone pairs and 5 electron domains. And as you can see, we got a lot of static electricity going on with my hair. Alright, and for the last one, we're going to do octahedral. I think that it pronounces that way. And this we'll be using sulfur hexafluoride. And as you see, I have 6 electron domains around the central atom. And this particular molecule has no lone pairs. Alright guys, thank you for tuning into my channel and letting me explain electron domain geometry using the VISPAR theory. If you'd like to know more, let me know. Alright.